Okay, so I thought I would go through some samples of some practice problems from this electron configuration practice worksheet number 1. There will be 2 total practice worksheets. It's a lot of practice, but because the reason for that is the more practice that you get, the better you get at this thing. So keep in mind, you are not going to be allowed to use this periodic table for your test. So I will have out my colored one today for the sake of the explanation that you guys might need from today's video. But if you can start trying to finish the rest of the practice worksheets without that, that may be definitely something that I would encourage. Okay, so what we're gonna do is I actually want to start with these questions up at the top. So not only are y'all gonna have to do electron configuration of just answering stuff like 1s2, 2s2, 2p6, you're gonna have to answer these kind of abstract questions about what is going on in the electron cloud. And so you're going to see questions like this that are like, how many sublevels and orbitals, and you were going to be like, I don't know anything. You do. We have turned some of these words like sublevels and orbitals and energy levels into mean something else in our electron cloud hotel. So I want us up here at the top to remind ourselves that the energy levels equal floors. I want us to remind ourselves that the sub-levels equal rooms. I want us to remind ourselves that the orbitals equal beds. So the way that I do these problems, and I've been doing this a long time, I immediately cross off any of these super scary science words and write above it floor, room, bed, and then you can more easily visualize your electron cloud hotel, and your periodic table can help you, showing you how many beds are in a P room or how many electrons can fit in a P room, and then it is so much easier to answer these questions. So let's go ahead and do that for the first question. The first question says, how many sublevels? I don't like the word sublevel. No, thank you. I like how many rooms does the second energy level, I don't like that, the second floor contain? So now this question has become, how many rooms or how many types of rooms does my second energy level contain? Now you can look at your picture of your electron cloud hotel, okay? Or if you're like, I don't know, remember what that looks like, you can also look at your periodic table. Second energy level, that is everything that starts with a 2. I only have an S room and a P room. And in fact, if I get my hotel, I only have that S room and that P room. So this question becomes super easy. It's like, how many rooms does the second energy level contain? Well, an S and a P. So that is 2. That is 2. That is how many sublevels the second energy level has. Okay, I love that. Is so helpful. Helpful for me. Okay, next question is how many orbitals? Orbitals is a bed. So how many beds does a P room contain? So I can be like, okay, a P room, a P room, a P room, a P room. If you can't remember what your electron cloud hotel looks like, guys, your periodic table helps you out. Remember, our P block is 6 elements wide to represent 6 electrons that can fit in it. Well, they are going to be fitting in 3 beds. Okay, so this question is, how many beds does a P sublevel contain? And a P sublevel, I keep putting my hotel down, and I don't know why I'm not going to remember to just keep it up here. I'm not going to remember a P room. Y'all, he's got 3 beds. So that made things easier. So it is 3. And off to the side, if you want to remind yourself that you got that because you knew a P room has these 3 beds in it. Okay, and sometimes drawing things out does help in some way. The next question is, how many total electrons can the 4th floor hold? So you're like, oh my gosh. So there are a few ways to do this. You can totally look at the periodic table and be like, okay, the 4th floor is everything going on here and here and here and then also here. Okay, so he's got all 4 rooms, right? I can count all of the elements in all of those rooms that way, which is a great option. Or you can also, just knowing that there are 2 electrons that can fit in each bed in those rooms, you can add it up that way. There are lots of options. I think what I'm going to do is I'm just going to kind of remember I have an S, P, D, and F rooms, right? So my S room can totally fit 2 electrons. My P room can totally fit 6 electrons, and that's what you're seeing here. My D room can totally fit 10, and then my F room can fit 14. So if I'm adding all of those numbers up together, and do not worry, you will always have a calculator in my class, but let's see if I can do this mentally just for an exercise of me not aging so quickly. I have 2 plus 6, which is 8, plus 10, which is 18, and 18 plus 14 is actually 32. You could also count 32 by going from your 4S and then your 4P, counting all those, and then your 4D, and then your 4F, okay? That is an option as well. So I would say 32. Next question is, how many electrons can an F room hold? Well, you can visualize your F room with all of his 7 beds, or you're like, this question is literally asking how many electrons is in that F room, and that takes up a space of 14 element blocks. So we have 14. So this is getting a lot easier for us, which is amazing. Okay. Now, this next question is a little sneaky. It says, which has a higher energy? 1s, 3p, 4s, or 3d? Well, we know the further away we get from the nucleus, the higher energy it is. And the energy levels are represented by these big numbers, right? Well, the biggest of the big numbers that I see is 4. That means there's something in the 4th energy level here. Well, the 4th energy level is further away from the nucleus than the other one, so that means it's going to have higher energy. So my highest energy electrons are going to be found in those outermost energy levels, S and P sublevels. Okay, I'm only going to do a couple from this section. I mostly wanted to focus on this because these questions do pop up kind of frequently, but they are not hard once you translate it into the hotel and just create that analogy to help you map out the picture a little bit clearer. Okay, so it says write the full electron configuration for the following neutral elements. So I'm telling you they are neutral. I'm not adding or gaining electrons, or gaining or losing electrons from the atom. I'm going to hop on down and just do a couple just to remind ourselves if we are, our brains are falling apart and we have forgotten everything we know. Let's do nitrogen. So nitrogen, he is right there. Atomic number 7, which means my notation for nitrogen is going to represent 7 electrons, right? So we're going to start at 1s. And to get to nitrogen, we are going to go 1s2, 2s2, 2p, stopping at nitrogen in the 2p room, so 2p3. Okay, so that is our electron configuration notation. If I were to ask valence electrons, that is the outermost energy levels, S and P. Sorry, that was supposed to be, I don't know why I rewrote 2p. 2p3. So my outermost energy levels, S and P. So nitrogen has 5 valence electrons. And we will come to learn that everybody in the 15th group, our column of the periodic table, does have 5. So that is how we get that. Okay, I also want to hop down and do krypton maybe. So krypton is going to be this guy right here. So he is atomic number 36. And since I've told you these are neutral elements, he will also have 36 electrons. So those 36 electrons filling up the hotel will stop directly on that 36th spot as I'm cruising through. So I'm going to have to cover up my periodic table a little bit to get down to krypton, or maybe not. Maybe I can do this, but we'll still be missing a bit of it, which is fine. Okay, so I'm going to start at 1s, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. I always like to, every now and then after I get going in a groove, like stop myself and be like, okay, have I passed my element yet? And I have not. So I'm at 4s2, but keep in mind when you go after 4s, that hits 3d because my blocks start at 1, 2, 3, and then 4. Okay, so I did 4s2, then I go 3d all the way through the 3d room, 10. And then to get to krypton, I go fully through that 4p room. So that would be a 4 2p6. I always like to check for my valence electrons, the outermost energy levels, S and P. So that would be this part, right? We got 2 plus 6, that would be 8, which makes sense. 8 valence electrons is stable, so we have a noble gas there. Okay, I want to bounce down into this section right here. So this section right here, I've given you some answer choices, and it says, base your answers for question 15 through 19. So 20 is a separate question, and that is one I also want to do here in a second. So on the following configurations that I've listed here. So you have a couple of ways to do this. Well, each question says, which configuration above shows a different element? So you can get to the question and write the configuration and see which one it maps to. Or you can look at the configuration and find it on your periodic table to see what element that would represent. And this is not something that we have done yet. So I thought I'd take the opportunity to kind of ignore the questions first and then do the labeling of what elements those actually are. Also, it's a little bit less writing because I'm not having to write 1s2, 2s2, all that stuff. So let's start with this first one. 1s2, 2s2, 2p6. You can follow with your periodic table as you're going. But I always just kind of like to jump to the ending of the configuration. God, that is really where I'm supposed to be ending up. Looks like after 2p6, I got 3s1. So the element that stops one place into the 3s stream, that's sodium. So I'm actually going to write that right here, Na, because that may be useful moving on down to the questions. 1s2, 2s2, I'm stopping at 2p2. Who is the 2p2 representative? 2p2, that's carbon. 1s1, hydrogen, right? 1s2, 2s2, 2p4, 4 places into the 2p room, we got oxygen. 1s2, 2s2, 2p6, all the way through that 2p room now, that is going to be neon. And then 1s2, 2s2, 2p5, that's going to be fluorine. So that was a little bit faster than having to write the configuration for each question. Now let's see if we can just do a little matching. So which one shows neon? That is going to be answer our selection E. Which one shows carbon? We said that that was B for us. Which one shows sodium? That was A. Which one shows fluorine? That was F. And which one shows oxygen? That was D. Nice. So you can also, if I give you the configuration, identify what element it is just by seeing what the ending tracks as on your periodic table. So the next one I want to do is I want us to review some of these sneaky ions. It says write the full electron configuration for a chloride ion. So Cl with a -1 charge, minus, 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 that's an anion. An anion gains electrons. He has gained 1 electron. So normal neutral chlorine is going to have 17 electrons. He does not have 17 electrons. He has 1 more than that. He has 18. So I'll be writing configuration for an element that now has 18 electrons. Well, guess what? Neutral argon also has 18 electrons. So this this electron configuration will look like the configuration of argon. So once again, that term of isoelectronic elements, different elements or ions that have the same number of electrons, we could say that this chlorine ion or chloride ion is isoelectronic with argon. So we're going to write the full electron configuration to get to argon right there. So we have 1s2, 2s2, 2p6, 3s2, 3p. Now, if it was just neutral chlorine, he'd be 3p5, but he is now an extra electron, so not 3p5, 3p6. He looks like argon. Cool. Amazing. So we're going to say isoelectronic with argon. Okay. Now I'm going to flip to the back and do a couple of problems from the back. I think I may do 4. So that's not a couple, but that is super fine for me. So this is a great just kind of drill through section of making sure that we are completely understanding this. I want to do the first one, which is potassium. and then I'll do sulfur, and then I'll do this one because he's an ion, and sometimes it's good to get some practice on it, so the phosphorus ion. And then last one we're going to do is we're going to do the lead with a +2 charge, so the lead ion. I do not actually want us to worry about this silver. You can write the electron configuration for silver, like that is absolutely a possibility for you to just write 49, but I will let you know on my answer key that you will see something different than ending at 49. That's because silver is an exception to some of the configuration rules. So do not freak out. You do not have to do that one if you are already feeling like, oh gosh, I'm nervous about it. You don't have to do it. Okay, let's do the first one. So potassium, find potassium on the periodic table. Potassium, potassium, potassium. There he is. Atomic number 19. Oh, and I've given you a place to write. Well, how many protons does he have? 19. He is neutral. I don't see any charges, so he has 19 electrons. See how this stuff kind of builds on each other. So my electron configuration notation for potassium, I'm going to zoom out now, is going to be 1s2, 2s2, 2p6, 3s2, 3p all the way through is 6. And then to get to potassium, 4s1. Okay, so that's the full electron configuration notation. How many valence electrons does he have? Well, the outermost energy level is the 4th. The ones that are in the S and P, I only have an S, and it is 1 electron. Potassium is also in group 1, where everybody has 1 electron. My noble gas configuration for potassium, the noble gas that is behind him on the energy level underneath the 4th energy level is going to be argon. So I would write argon in brackets, and starting at argon to get to potassium, you have 4s1. Okay, let's do the next one, sulfur. Sulfur is atomic number 16. So he's got 16 protons. I don't see a charge of a plus or a minus, so he also has 16 electrons. So his configuration to get to him is going to be 1s2, 2s2, 2p6, 3s2, 3p4. The number of valence electrons, his outermost energy level is the 3rd. The S and P electrons are 2 and 4. 2 plus 4 is 6 valence electrons. Sulfur, also being in the 16th group of the periodic table, will have 6 valence electrons. Noble gas configuration, hop up to the noble gas behind him, is neon. And to get from neon to sulfur, we got 3s2, 3p4, which shows you the ending part of my configuration from the full way. Okay, I'm now going to hop down here. So we're going to do phosphorus with a -3 charge. Now, I always like to, especially when I'm feeling a little uncomfy about these charges and these ions and what that means, I kind of like to make notes, okay? So I see that, I get a -3, -3. What would the atom have to do to get a -3 charge? So that's an anion. And if you're like, oh, I don't remember, well, he's not a cation. We like to say cats are losers. So, oh, okay, that must mean that anions are gainers, right? So this means he has gained 3 electrons. Okay, so that's helpful to know, because now when I go pick up how many protons phosphorus has, which is 15, I now know that he has 3 more electrons than that 15. So 15 plus 3 is he's got 18 electrons. And once again, the number of positive charges and the number of negative charges, I have 3 more negative charges than I have positive charges. So that's where that comes into play. So now he's going to start to attempt to look like an element that has also 18 electrons. Neutral argon has 18 electrons. So I'm not going to stop at phosphorus. I'm going to move 3 more places over to represent the 3 electrons that he has gained and write configuration all the way through the 3p room. So I've got 1s2, 2s2, 2p6, 3s2, 3p. It's not 3p3 like a neutral phosphorus. It is 3p6 because he has gained 3 electrons. And as a result of that, when I'm counting up valence electrons, my outermost energy level is the 3rd. I have 8. We're getting that 8 that we love to get because he has gained 3 electrons. So we would also say that he is isoelectronic with argon. They are different elements and ions of each other, but they both have 18 electrons in this case. Noble gas configuration. Okay, so for the noble gas configuration for this one, behind we've got neon, right? So then I will write neon, and then all the configuration that it takes for us to complete to get to the end where we stopped. So then we would go 3s2, 3p6. Okay, last one I'm going to do on this page for you guys, and then I think we will feel a little bit more confident, is this lead ion. Oh my gosh, oh my gosh, oh my gosh. Positive, cation, because cats are positive, and they are losers, so this tells me he has lost 2 electrons. So if we find lead, he is right there. So he's got 82 protons. Okay, his number of electrons is not going to be 82 because, got a charge. We've mentioned he's lost 2 electrons. So that means it is not 82 anymore like a neutral lead would be. It is 80. So he's not going to occupy 82 spots in this hotel. He's going to occupy 80 spots in this hotel with only his 80 electrons. So he's trying to look like Mercury, okay? So we could even say lead with a +2 charge, that lead cation is isoelectronic with mercury, a neutral mercury, because they would both have the same number of electrons. So this one is going to be a long way to get to mercury, but here we go. We are ready. 1s2, 2s2, 2p6, 3s2, 3p6. I'm going to pop my periodic table up here and zoom out because as we get a little bit crazier, I want us to make sure we're tracking and following ourselves. Okay, so after we have 3p6, we hop down to 4s2. After 4s, we run into 3d, 3d10. And then after 3d10, we run into 4p6. Check yourself, make sure you haven't gone too far. I'm definitely not too far. I still got a way to go. So after 4p6, we go to 5s2. After 5s, we go to 4d. Still need to go all the way through, so 4d10. After 4d10, we go to 5p6. We're still not there. After 5p, we go to 6s. 6s2. Then after 6s, we hit that dark line. We're like, oh, drop down, hit 4f. The 4f room has 14. After we get done with 4f, we go to 5d. Y'all, we are still not there. So 5d10. And then after 5d, we go, wait. I almost started to write the full configuration for lead for a neutral lead. In fact, I kind of will do that because this will help us remind us how we manipulate to make ions. So if this was neutral, we would totally have, so this is 6p, right? We would totally have 6p2. But we said he is trying to look like mercury. So those 2 electrons that he has lost, this is a great review actually. So those 2 electrons that he has lost are going to be the 2 electrons in his highest energy level. Now, I want us, oh gosh, this is a great review. I want us to actually look here. I've got 2 parts of that configuration that are his highest energy level, right? So do I remove the S ones or the P ones? Well, the P ones are going to be higher energy than the S because it's further in the configuration, and P electrons are higher energy than S electrons, even if they are on the same energy level. So if he's losing those 2 electrons, he is losing from that 6P, and both of those 6P electrons go away, which means that's his final notation. Okay, so that is what that looks like. And now if we were to count valence electrons, outermost S and P, well, I got rid of the outermost P, so my outermost S is this one right here. So lead has 2 valence electrons. Now I also want us to notice here Wait a minute. She said that stuff in group 14 has 4 valence electrons. Not necessarily, especially when I cross through to this side of this staircase and get heavier and heavier. Some of these metals in this area get weird oxidation numbers, or oxidation numbers. Well, you haven't even heard that term yet. They get weird numbers of valence electrons due to the nature of their energy levels being very high. So then finally, my noble gas notation. So to get to lead, well, actually to get to the spot of mercury, another element that has 80 electrons, we would have to start with xenon first. So we're going to go xenon. And then after xenon, we go into the 6s2 room, 6s2. And then we go 4f14. And then we go 5d10. Amazing. Okay. I think that's all the ones I want to practice with you guys from this practice assignment. Hopefully, if you were very confused, that got you on a better trajectory to complete the rest of the assignment. And have fun cranking out some electron configuration.